AI has come a long way with models like ChatGPT and Llama 3 that can handle language tasks like writing and coding pretty well. But when it comes to making decisions in complex multi-step situations, like organizing an international trip, coordinating flights, hotels, car rentals, and activities across different countries, if it misses a flight connection or books the wrong hotel, the entire trip could be thrown off course. Until now. That's when Agent Q comes into play. The team at the AGI Company, working with folks at Stanford University, set out to tackle this exact problem. They wanted to create an AI that's not only good at understanding language, but also capable of making smart decisions in these kinds of complex, multi-step tasks. What they came up with is pretty impressive. Let's break down how Agent Q works and why it's so different from other AI systems out there. Traditionally, AI models are trained on static data sets. They learn from a massive amount of data, and once they've seen enough examples, they can perform certain tasks reasonably well. But the problem is, this approach doesn't work as well when the AI is faced with tasks that require making decisions over several steps, especially in unpredictable environments like the web. For instance, booking a reservation on a real website where the layout and available options might change depending on the time of day or location can trip up even advanced models. So how does Agent Q solve this? The researchers combined a couple of advanced techniques to give the AI a much better chance at success. First, they used something called Monte Carlo tree search, or MCTS for short. MCTS is a method that helps the AI explore different possible actions and figure out which ones are likely to lead to the best outcome. It's been used successfully in game-playing AIs, like those that dominate in chess and Go, where exploring different strategies is key. But MCTS alone isn't enough because in real-world tasks, you don't always get clear feedback after every action. That's where the second technique comes in, direct preference optimization, or DPO. This method allows the AI to learn from both its successes and its failures, gradually improving its decision-making over time. The AI doesn't just rely on a simple win or lose outcome. Instead, it analyzes the entire process, identifying which decisions were good and which ones weren't, even if the final result was a success. This combination of exploration with MCTS and reflective learning with DPO is what makes Agent Q stand out. To test this new approach, the researchers put Agent Q to work in a simulated environment called WebShop. This is essentially a fake online store where the AI has to complete tasks like finding specific products. It's a controlled environment, but it's designed to mimic the complexities of real e-commerce sites. And the results? Agent Q outperformed other AI models by a significant margin. While typical models that relied on simple supervised learning or even reinforcement learning had a success rate hovering around 28.6%, Agent Q, with its advanced reasoning and learning capabilities, boosted that rate to an impressive 50.5%. That's nearly double the performance, which is a huge deal in AI terms. But the real test came when the researchers took Agent Q out of the lab and into the real world. They tried it on an actual task, booking a table on OpenTable, a popular restaurant reservation website. Now, if you've ever used OpenTable, you know it's not always straightforward. Depending on the time, location, and restaurant, the options you see can vary. The AI had to navigate all of this and make a successful reservation. Before Agent Q got involved, the best AI model they had, Llama 370B, had a success rate of just 18.6% on this task. Think about that. Only about 1 in 5 attempts actually resulted in a successful reservation. But after just 1 day of training with Agent Q, that success rate shot up to 81.7%, and it didn't stop there. When they equipped Agent Q with the ability to perform online searches to gather more information, the success rate climbed even higher to an incredible 95.4%. That's on par with, if not better than, what a human could do in the same situation. The leap in performance comes from the way Agent Q learns and improves over time. Traditional AI models are like straight-A students. They excel in familiar scenarios but can struggle when faced with the unexpected. In contrast, Agent Q acts more like an experienced problem solver capable of adapting to new situations. By integrating MCTS with DPO, Agent Q moves beyond simply following predefined rules, instead learning from each experience and improving with every attempt. One of the challenges the researchers faced was ensuring that the AI could make these improvements without causing too many problems along the way. When you're dealing with real-world tasks, especially those involving sensitive actions like online bookings or payments, you need to be careful. An AI that makes a mistake could end up reserving the wrong date, or worse, sending money to the wrong account. To handle this, the team built in mechanisms that allow the AI to backtrack and correct its actions if things go wrong. They also used something called a replay buffer, which helps the AI remember past actions and learn from them without having to repeat the same mistakes over and over. Another interesting aspect of Agent Q is its ability to use what the researchers call self-critique. After taking an action, the AI doesn't just move on to the next step. It stops and evaluates what it just did. This self-reflection is guided by an AI-based feedback model that ranks possible actions and suggests which ones are likely to be the best. This process helps the AI fine-tune its decision-making in real time, making it more reliable and effective at completing tasks. Now, we mentioned earlier that the Llama 370B model had a starting success rate of 18.6% when trying to book a reservation on OpenTable. After using Agent Q's framework for just a day, that jumped to 81.7%, and with online search capability, it hit 95.4%. To put that into perspective, that's a 340% relative increase in success rate from the original performance. And when you consider that the average human success rate on the same task is around 50%, it's clear that Agent Q isn't just catching up to human-level performance, it's surpassing it. What's also fascinating is how Agent Q handles the complexity of real-world environments compared to simpler, simulated ones like WebShop. In WebShop, the tasks were relatively straightforward, and the AI could complete them in an average of about 6.8 steps. But when it came to the OpenTable environment, the tasks were much more complex, requiring an average of 13.9 steps to complete. Despite this added complexity, Agent Q was able to not only handle the tasks, but also excel at them. This shows that the AI's ability to learn and adapt isn't just a fluke, it's robust enough to deal with the kind of unpredictability you'd find in the real world. But this isn't to say everything is perfect. The researchers are aware that there are still some challenges to overcome. For one, while Agent Q's self-improvement capabilities are impressive, there's always a risk when you let an AI operate autonomously in sensitive environments. The team is working on ways to mitigate these risks, possibly by incorporating more human oversight or additional safety checks. They're also exploring different search algorithms to see if there's an even better way for the AI to explore and learn from its environment. While MCTs has been incredibly successful, especially in games and reasoning tasks, there might be other approaches that could push the performance even further. One of the most interesting points the researchers raise is the gap between the AI's zero-shot performance and its performance when equipped with search capabilities. Zero-shot means the AI is trying to solve a problem it hasn't seen before, and typically this is really challenging. Even advanced models can struggle here. But what's fascinating about Agent Q is that once you give it the ability to search and explore, its performance skyrockets. This suggests that the key to making AI more reliable in real-world tasks isn't just about training it on more data. It's about giving it the tools to actively explore and learn from its environment in real time. So essentially, we're looking at AI systems that can handle increasingly complex tasks with minimal supervision, which opens up a lot of possibilities. Whether it's managing your bookings, navigating through complicated online systems, or even tackling more advanced tasks like legal document analysis, the potential applications are vast. And as these systems continue to improve, we might find ourselves relying on them more and more for tasks that currently require a lot of manual effort. All right, if you found this interesting, make sure to hit that like button, subscribe, and stay tuned for more AI insights. Thanks for watching, and I'll catch you in the next one.